Okay, let's do a quick video on solving log equations. Now that we know our log properties, we can use them to help us to solve more complicated log equations. So here's one with several terms in it. Log to base 2 of negative 2x plus log to base 2 of 3 minus x equals 3. All right, so the definition of a log says that log to base b of a, if log to base b of a equals y, then b is the base, a log is an exponent, y is the exponent, and that equals the argument of the log. Well, I can't use that right now because I have more than one log, so I'm going to use my log properties to condense my log statement. So that means since I'm adding logs, I can multiply their arguments and write one log of negative 2x times 3 minus x, and that equals 3. Now I have one log, and so I can use my definition of a log. 2 is my base, 3 is my exponent, so 2 to the 3 equals, and then the argument, negative 2x times 3 minus x. All right, 2 to the 3 is 8, and then this is negative 6x plus 2x squared. So it's a simple quadratic equation. Just going to rewrite it in order. So 2x squared minus 6x, and then I'm going to move the 8 to this side, which means I'm going to subtract 8, equals 0. Well, everything can be divided by 2, and the 2 can go away, so then I have x squared minus 3x minus 4 equals 0. And this is easily factored, so it's x minus 4 times x plus 1 equals 0. Multiplicative property of 0 says that this is true when x minus 4 equals 0, or x plus 1 equals 0. So that means that this is true when x equals 4 and negative 1. All right, well, logs have a domain issue. So we have to see if 4 or negative 1 is in the domain. Negative 2x has to be greater than 0. All right, well, if you divide by negative 2, remember you flip the inequality sign, so that means that x has to be less than 0. All right, well, 4 is not less than 0, so 4 cannot be my answer. All right, well, let's go to this statement. 3 minus x also has to be greater than 0. Your argument of your log always has to be greater than 0. So if I move the x over here, then I get this statement. And remember, you always read an inequality starting with the variable. So this is x is less than 3. Well, negative 1 is less than 3, so we're good. So negative 1 is my answer. It does satisfy the domain. All right, so, or it's in the domain. So let's do another log. This is a simple one. Now, it won't look simple to everyone because some people have a hard time reading very similar math statements. So they almost look identical, the left and the right side. The difference is that x minus 1 is the argument of my natural log on the right, but only x is my argument of the natural log on the left. So I want to get the natural logs together. So I'm going to subtract, well, I tell you what, I'm going to add the 1 first. Let's add the 1 first and move him over there. Natural log of x, and then equals, and then my natural log of x minus 1, and then plus 1. All right, so I just moved the 1 over. Now I'm going to move this natural log over here. Natural log of x minus 1. We're going to move him to both sides, to the other side. And so now we have the natural log of x minus the natural log of x minus 1 equals 1. All right, well, the second log property, again, I can't use this until I have one log. The second log property says that when I'm subtracting logs, then I can write the arguments as a quotient. So I've got x, the argument of the positive log, divided by x minus 1, which is the argument of the negative log. All right, and so that's going to equal 1. The natural log, the base for the natural log is e. So I can use this now to write this as an exponent. E is my base. 1 is my exponent, you see, because he's on the other side of the log. And that equals x over x minus 1. So this is just e, just a number. So I'm going to multiply both sides by x minus 1 to get rid of the denominator. Okay. And so the denominator then ends up being over here. E times x minus 1 equals, and on this side, the x minus 1's cancel, and I just have x. All right, I'm solving for x. Remember, e is a number. So we just multiply through by e. And now I need to get my x terms on the same side. So I'm going to subtract dx, subtract dx. And I have negative e equals x minus ex. I'm solving for x. I want to factor the x out. 1 minus e equals negative e. Now I divide both sides by 1 minus e. All right. And so let's move our answer up here where we can see it better. X is equal to negative e over 1 minus e. Now, that's got more negative signs than I like, so I'm going to factor the negative out of the denominator and cancel it with the negative sign in the numerator so that the numerator is positive now. And the denominator is now e minus 1. So this is my value for x. Let's see if it is in the domain for this equation. Well, first of all, x has to be greater than 0. Well, e is about 2.7. And so 2.7 over 2.7 minus 1, which is 1.7. So 2.7 over 1.7 is just an estimation. It's just an estimation, but this is like 27 over 17. Is that greater than 0? Yes. So this is fine. This answer is fine for this domain. What about that one? Well, that one says that x minus 1 has to be greater than 0, so x has to be greater than 1. Well, again, my estimation of 27 over 17, that's bigger than 1. So, yes, in fact, this answer works. It's in the domain for both log expressions. So this is going to be the answer to that one.